this video, we're going to look at rational exponents. So rational exponents, you can almost think of them as having a fractional exponent. So for example, I have x to the 3/4, which is an example of a rational exponent. You'll notice that I have a fraction as the exponent on the x value. Now the way I remember this is the top number always represents the power. If you're powerful, you're kind of on top, so I just kind of use that analogy to remember that the top is the power. And then, just like tree roots or any type of roots of plants, they go under the ground. So your root goes underneath, or it's on the bottom. So I kind of use analogies like that to remember that the power's on top and the root's underneath. Now, the big idea here is that we can take a rational exponent and we can rewrite it two different ways. One way we can rewrite it as our base is still an x, but you'll notice that our power on the x is 3 because that's our power on the rational exponent, and then we're taking it to the 4th root because what's on the bottom is the 4th root. Or I could write this as x to the 4th root taken to the 3rd power. So when I rewrite it as a radical form, okay, this is in radical form, you'll notice that it doesn't matter whether I write the power first, then the radical, or the radical first, then the power. The only thing that matters is that the 3 is the power and the 4 is the root. Now we can use this idea to evaluate different numbers. So suppose I look at this first example here where I have 27 to the 5/3 power. Well, I can really rewrite this as 27 to the 3rd root taken to the 5th power. Now, anytime you're evaluating an expression to figure out what it's equal to, it's always smart to take the root first. The reason why you want to take the root first is because it gives you smaller numbers that you can then multiply to get the power from. If you take the power first, usually the number will get too big to really be able to find roots easily. So if I go ahead and take the 3rd root of 27, well, the 3rd root of 27 is just 3, and then if I take 3 to the 5th power, well, that's really just 3 times 3 times 3 times 3 times 3. 3 times 3 is 9, 3 times 3 is 9, times 3, and then if I take 9 times 9, that's 81, 81 times 3, well, that's just going to be 243. So 27 to the 5/3 power will be equal to 243. Alright, just one last example here. Suppose I have 3 to the x, 3 times x taken to the 2/3 power. Well, in this case, the biggest thing to recognize here is that this rational exponent is on the x term. It's not on the 3. Right now, the exponent on the 3 is a 1. So when I rewrite this in radical form, if I switch this to radical form, it's going to be 3 times the 3rd root of x taken to the 2nd power. Notice that the 3 stays on the outside because it did not have the rational exponent on it.